Assalamu alaikum. We will correct some exercises about complex numbers and parabolas. Let's start with complex numbers. Questions 18 and 19 are similar and very easy. You have a complex number, 31 plus 50i. And as you can see, there are two parts here, 31 and 50i. But we won't consider this I for this question. We will just extract these parts, 31 and 50. And we will say that this complex number is, in fact, a point. The coordinates of this point are 31 and 50. This is what is meant by what point is in the complex plane represents this complex number. So the point is 31, 50, and the answer is easy, D. Okay, next. Question 19, you can find the correct answer now. You will have a complex number, negative 98 plus 61i, and you can guess which point represents this complex number. Question 20. Of course, at any point you can pause the video and practice or review or just take a break. Or so we will continue with question 20 now. We said that complex numbers can be identified to points, can be considered as points. Here we have two complex numbers. So it's like we have 2 points, negative 30 plus 19i, the first point, and the second point is negative 3 minus 10i. So we have 2 points. That's why the question here is, what is the midpoint? So we are looking at looking for the point in the middle here. We have a formula. Of course, you won't graph anything. You just use the formula. To find the midpoint, the coordinates of the midpoint, you just add first parts, divide by 2. That means negative 30 minus 3, add them and divide by 2. So negative 30 added to negative 3, divide by 2. And then the second, the imaginary parts, you do the same. 19 added to the second, the imaginary part of the second complex number is negative 10. So you add negative 10 and divide by 2. Use your calculator. This is negative 16.5 and this is 4.5. The correct answer, you have a point, negative 16.5 as first part, as real part, and 4.5 as imaginary part. So the correct answer is B. Now you can practice using the same formula here. Question 21. We have two complex numbers, and the question is to find the midpoint. Which of these is the midpoint of these complex numbers? Next question, the modulus. The modulus, the meaning of the modulus. Okay, I'll remove this. The meaning of the modulus, if you consider a complex number, what's the modulus of a complex number? So a complex number can be represented as a point. Let's say this is the point in the coordinate system. This is the origin. The modulus is just this distance between the origin and the point. This is the modulus. We generally use R for the modulus. So the modulus is the distance between the origin and the point. If we consider that this is point A, of course, the coordinates are 15, 2 here, as you already learned in the first question, 15, 2. This is the corresponding point. So this is the modulus, and you don't have to graph anything. You just have a formula you use the formula and select the correct choice. The modulus can be calculated using this formula. First part squared, 15, real part squared, imaginary part squared. The imaginary part is 2 here, and then add them and apply square root. Okay, so here 15 squared, 225, plus 4 is 229, and don't forget the square root, so the correct answer is A. Now you practice with question 23. You can pause the video and practice find the modulus of this complex number. The distance now between two complex numbers. I will repeat everything. So again, you have two complex numbers. That means that you have 2 points, and it makes sense to find the distance between these 2 points. Again, you have a formula. So the formula is this: the distance. We will use it first, and then we'll give the formula. So you understand it first. So how to find the distance between these 2 points of these 2 complex numbers? Again, square root of. Now, the difference between the first parts, that means -8, this is the first part of the first complex number, and 2 minus 2 squared plus, same thing for the second parts, the imaginary parts. You have 2 here and you have -10 here, so you will write 2 here and you will write -10 here, and you calculate the difference between these 2 complex numbers. So you have to calculate the difference, but here the second number is already negative, so you have the negative sign of the formula, the minus sign of the formula, and you have the negative sign of the number, so you have to put both of them. In the formula you have minus first number minus second number. This is the first number and this is the second number. The second number is already negative, so don't omit the sign of the second number or the minus sign. Both of them must be used here. And of course, you can calculate using your calculator. And we'll do this together. So here, square root of difference between real parts, difference between first numbers, -8 minus 2 squared, then plus difference between the second numbers, 2 minus, and the second number is -10. So put both signs here, the minus sign and the negative sign. Close both brackets because we opened 2 brackets here, so we have to close 2 brackets and squared equals, and you get the result in its simplified form, in its best form, most simplified form, which is 2 square root of 61, which is answer B. Okay, now a question for you to practice. Calculate the distance. So if you understood this, then you would be able to apply it to these 2 numbers here. -2 plus 6i and 4 minus 4i. The question is calculate the distance between these 2 numbers, and the formula is, we write the formula in general. So -8 is the real part of the first number, x8 minus xb squared plus ya minus yb squared and square root all of this. First part, the difference between the real parts, plus squared, of course, plus the difference between the imaginary parts, the second part squared. This is the formula. This is D. Okay. Now questions 25, 26 are excluded from the next quiz. So I won't answer them. Question 27, you have a complex number, but the complex number is presented in a new form, different form. This is not the usual form. This is the complex number. 10 CIS of pi. 10 CIS of pi. This is multiplication. 10 times CIS of pi. CIS stands for, this is just a notation here. Don't focus on CIS too much. This is just this is just to say that this is not the regular form of a complex number. This is the polar form. This is the call it polar form, and it is an abbreviation. It is a shortcut of cosine, sine, and the letter I here. The same I that we've been using so far. So this is just a complex number, the polar form of complex number. Now, what's important here is these two numbers, 10 and pi. 10 is the radius or the modulus, not the radius, the modulus, but we use the letter R. R for it. It's similar to the radius. In some contexts, it is a radius in some way. If you use the graph, if you graph the complex number, it is a radius. Because the modulus, we said that the distance between O and A, it's like the radius of a circle. That's why we use R here. But we call it the modulus. For complex numbers, we call it modulus. And pi is an angle. We call it argument. Or angle, doesn't matter. Now this is the polar form of complex number, and the question is to find the other form. So one complex number can be presented in two forms. The same complex number can be presented in its normal form, which is rectangular form, the same form that we've been using so far. This is the rectangular form. Sorry, this is the rectangular form. All of these are rectangular. This is rectangular form. This is rectangular. All of these are rectangular forms. And when you are given the polar form, how to find the rectangular form? Just use these two formulas. You want the rectangular form. That means that you want a number in this form. Something plus I something. 2 plus 2i. 3 minus 8i. Something like this. So you are looking for A and B. And A and B are given with this formula. A is R cosine of the angle. It's pi here. So it is 10 cosine of pi. And B is equal to R. Same thing, but instead of cosine, use sine for B. 10 sine of pi. And don't forget, you are using trigonometric functions, but you are using pi, and pi is a radian angle, so use radians in your calculator. This is very important. Here my calculator is already set to radians. You can see the small r here, the small r here above on the top line, small r. But if it is set to degrees like this, then you can change it as usual using shift mode and 4. So ensure that you get this R on top before using this formula, using cosine of pi, cosine of a radian angle. So 10 cosine of pi equals -10. And then 10 sine of pi. 10 sine of pi equals 0. So the rectangular form a plus ib is -10 plus I times 0. And I times 0 is just 0. So it will cancel. And you will get simply -10, which is answer B. Okay? So you can practice converting this. Question 28 will be cancelled for this quiz, but as practice for question 27, I suggest that you convert this complex number presented in its polar form into rectangular form. So instead of 10 CIS of pi, we already converted this into -10. Now, time to practice for you and convert 10 CIS of pi over 6. And you can also convert the second complex number too. Okay, but question 28 will be cancelled. Won't be included in the exam. Also question 29, also question 30 for this quiz, they are cancelled. So we are done with complex numbers. See you in the next video. I will explain parabolas.